Rain made of diamonds and ruby gemstones, 2,500-degree clouds filled with hellish liquid lava, and 350-year-old giant megastorms. This is the most extreme weather in the universe. Saturn is the second largest planet in our solar system, and its rings make it instantly recognizable. And personally, it's my favorite planet because it rains diamonds from its clouds. Scientists estimate that around about 10 million tons of diamonds are produced in Saturn's atmosphere every single year. Now, the sizes of those diamonds could vary a little bit, but they're estimated to be about a centimeter across. That's the size of a 4-carat diamond. But why does this happen?
We know that on Saturn there's carbon soot. The carbon soot is created by lightning. Lightning actually zapping methane in the atmosphere. The carbon soot precipitates or falls through the atmosphere.
As the carbon soot falls from the clouds, this same crystallization process occurs, but instead of taking billions of years, it happens in a matter of moments. Now, in order for a planet to have weather, it needs an atmosphere, the layer of gas that surrounds a planet. So for example, Earth's atmosphere is made of nitrogen, oxygen, argon, and a little bit of water vapor as well. The planet Mercury and our moon, on the other hand, they don't have an atmosphere, hence why they look like grey, lifeless rocks. On Earth, a cloud forms where it's too cold for water to stay as a vapour in the air. Now that can happen with other materials too, just at different temperatures. So it's essentially possible to have a cloud made of anything. But what about planets that are so hot that things that exist as solids on Earth are actually liquids and gases in their atmospheres? I'm talking about things like rock and lava. Imagine it being so hot that lava evaporates into the air, forming clouds, and then you get lava raining from the sky. 55 Cancri E is an exoplanet that's about 40 light years away from us. It orbits really close to its star. Not only that, it's also tidally locked, which means that one side of the planet always faces its sun, and it's always daytime there and it's boiling hot. The day side is permanently covered in an ocean of molten lava. It can be hard to picture what lava rain would actually look like, but volcanic eruptions here on Earth in places like Hawaii give us a hint of what it might look like.
Right here was the site of a massive eruption. All along this fissure, fountains of lava shot into the air nearly 100 meters high. The liquid lava droplets then cooled and solidified in the air before raining down onto the surface as these tiny pebbles. This is what we think the rain might be like on planets like 55 Cancri E.
Planet hunters and astronomers think they've found an exoplanet with the strangest rain in the universe. WASP 12b is an exoplanet 12,000 light years away. It's a gas giant like Jupiter, but it's twice as big and its atmosphere is 2,000 degrees hot. An atmosphere like that, we think the conditions would be just right to give us molten ruby rain.
And the way that it scatters light suggests that there are clouds high up in the atmosphere. At this part of the atmosphere, the temperature is around 2,000 degrees. So the most likely substance forming these clouds is an aluminium oxide called corundum, which forms the basis of rubies.
This crazy extraterrestrial weather doesn't stop at gemstone rain. There are planets out there that have the most gigantic storms that humankind has ever witnessed. We have Mars rover footage that shows us dust devils that are over a kilometre high. But impressively, the storms on Mars can reach up to 20 kilometres in altitude, and it's all down to Mars's atmosphere.
Its atmosphere is 1/100th the pressure of Earth's, and the effect of having that really low atmospheric pressure on Mars means that it can't trap any of its heat. So Mars is a cold, barren desert compared to Earth or to Venus.
The dust storms are so bad on Mars that every few years or so, they engulf the planet for months at a time. That's going to have a major impact on any future human missions that we send to Mars. These storms on Mars, though, are minuscule in comparison to what's been observed elsewhere in the solar system. We've sent probes and satellites to all of the gas giants and found some mind-blowing weather activity. The Great Red Spot is a storm on Jupiter that is twice the size of the entire Earth. It was first spotted by Giovanni Cassini through a telescope in 1665, which means it's been raging non-stop for at least 350 years.
That makes it the longest living storm that we know of. The outer planets are big balls of gas, and that makes a huge difference in the weather because you don't have continents, you don't have mountains for the winds to rub against, and there's nothing to control the weather the way the continents partly control our weather.
Saturn is the planet with the largest and most powerful storm in the solar system, covering 4 billion square kilometers. And we know about it because we've seen satellite images of it growing.
On December 5th, 2010, the radio receiver on Cassini started picking up the radio signal of lightning. And on the same day, the camera saw a little storm up in the northern hemisphere of Saturn.
Within 6 months, the storm grew so large that it wrapped around the entire planet and its head caught up with its tail. The truth is, life on Earth is a huge anomaly in our solar system, our galaxy, and even maybe across the entire universe. The majority of other planets are a lot less inviting.
So the planets that we've found so far aren't particularly nice places to go. They're not somewhere you'll put on your vacation list anytime soon.
So while we might not describe weather here on Earth as mild all of the time, astronomically speaking, mild is the most appropriate word. What makes Earth so habitable is this perfect mix of conditions that we have that essentially make it like a Goldilocks planet for life. And that includes our proximity to our star, the sun. Any closer and it would be a hellish inferno, and any further away it would be a frozen wasteland. So it could just be a matter of time before we find a planet that's similar to Earth. But what we do know is that warm, cold, wet, dry, windy and mild, all of these conditions work in perfect unison to keep us alive here on Earth. Essentially, we got lucky, so think about that the next time you want to moan about the weather.